So, thank you all for coming. I will turn this on real quick. My name is Gregor. I'm coding for a living for quite some time now. I'm also working here at AppCont with Robert. And I want to give a talk about coding, which in my opinion should be fun. At least to me it's fun. And I want to show you why maybe and how it would be more fun to you. So over the course of my career, I have learned or I have gotten into habits of keeping my code very much in order and have a very high focus on getting or achieving the best possible design I can. And it has not been like this from the start. I just developed these habits and it helped me have more fun at what I'm doing. The funny thing is, I'm not really an organized person. Like my wife would even say that I'm chaotic and I'm lazy and I'm not really concerned about cleanliness. But when I'm working on code, it's exactly the opposite. So that's that. Let me tell you this, expensive software, as I have seen, is not fun. And software should be simple, it should be cheap, and if you can do it, then it's usually cheap, and expensive is not fun. So what do I mean by that? I will give you a model about what I think the cost of software is. And I think the cost of software is the sum of the cost of all changes that you have to do in the code to build the software. So if you have experience with version control, maybe with Git, you can think of these things as commits, for example. Yeah, small steps, changes, and all of the changes together, all of the cost of these changes together is the cost of the software. And if you look at a single change, the cost of one change of these is, first of all, the communication. Because you have a customer, the customer needs something, he has a need, and there has to be some way you get what he needs from their head into your head, so to start coding. And there is management involved, there is a process involved, there is lots of stuff involved. The next thing on cost is the essential complexity. So you usually, or always, you have to solve a specific problem for the customer to fulfill their needs. And you have to achieve this, you have to get this complexity in your code. It is essential, there is no way to get around it. On the other hand, there is accidental complication. And the thing with accidental complication is, this is what we produce, because we are probably not as good as getting the best design initially. So, and everybody does this. It doesn't matter if you're a junior or if you're a master. You might get the code working at the first try, but you will never get it working, or you'll never get the code right on the first try. So if you get the code working, you're not done. First you have to get it right. And only if you get it right, then you really get a good product. Now, what do I mean by, well, let's first do what you should do in the correct order. So you want to first get it to work. That's the easy part. Then you want to get it right. And I will tell you what right is later. And then you want to make it fast. But usually when it's working and when it's right, it's already fast. So you don't have to care about it. Usually you don't really have to care about it. So this is why it's small. Fast, it's not that important usually. When is the code right? The code is right when it is working, when you can read it with ease. It should be very easy to read. When it is easily changeable, because as you have seen, there is a lot of changes throughout the development of the code that you have to do. And every one of these changes, just adding a feature, these are all changes. And it should be as simple as possible. And the thing is, easily changeable and as simple as possible, they kind of contradict each other. And there are trade-offs. So maybe if you make the code as simple as possible, it's not as easily changeable. But if you make it as easily changeable as possible, it might not be as simple as possible. So there are always trade-offs involved, and you have to make decisions of finding the best in the middle. So why easily changeable? Of course, customers, they change their mind all the time. So, but we can't really blame them for them. The business is flowing. It's always changing. There is lots of people involved with different needs, different opinions, and they have to communicate to everybody. Then some things get lost. And other than that, if we can't get it right on the first try, how can we blame them to get it not right on their requirements not right on the first time? So that's just naturally, and we should not blame them for it. Instead, we should try and make our code as easily changeable as possible, and then we don't get into issues, or we can stay fast. Okay. The funny thing is, we spend vastly more time reading code than we are writing it. Like from the Hollywood movies, like we are developers, we are hackers slamming the keyboards all the time, making magic happen, but it's not true at all. We are usually staring at our screens, just thinking, trying to figure things out, debugging, and this just staring takes a lot of our time. Coding is actually very minimal time. This is why you need to focus on readability. Also, this makes you a team player. So the code that you write is the code that the other people in your team have to read. And if you can make it very readable, you're a good team player. And even if you're working alone on your own project, you are your own team player like 2 weeks later. Because after 2 weeks, you will have forgotten most of the details, and then you have to start recognizing everything again. And if it's easy to read, it's much easier to get into the code. So you are also your own team player in this regards. In my opinion, slow is the new fast. I think when you're working on a software, you should really take your time and get it right, and get the best design that you can do, and in the end, it will usually pay off. For me, it has always paid off. And when I started, I did poor design, and as I got better, I noticed how I got faster. Like some people think I'm a fast coder. I'm not a fast coder. My code is good, that's why I'm fast. But I'm actually a very slow coder, so yeah. Okay. Also, most of the people think they have no time. But I think that's kind of an illusion. So the business needs it yesterday, or they need it in 2 weeks, or they ask you, when can you ship it? And you say, I need 4 weeks. And then they say, but I need it in 2 weeks. What do? Do you say, okay, I will try harder? You can't make magic happen. Maybe you can ask, what else can you give you in 2 weeks? Maybe something less that will fit your needs. And if they can answer with, you can do this and this, and maybe this works in 2 weeks, then that's fine. But if they say, no, I need everything, then you should say no. Like also, when you are working as a programmer and you want to be professional, you have to learn to say no in these situations. And getting into a rush, hurrying and having all this adrenaline, and when you are in this survival mode, it's usually that you're a sad coder, and it's not fun. If you have stress, it's not fun. So I don't recommend it. Also, this is an interesting curve. This is my experience. When you are starting very fast and you are doing everything quick and dirty, you might be on the right, so this is the red curve, then you might be faster in the beginning, but very soon, when you keep doing things like that, your speed will drop off significantly. And in extreme cases, after weeks or maybe months, you will have to ask yourself if you should not start over. Instead, what I recommend is to focus on this green line, to slow down a bit, to take your time to get it right, and at some point, at the tipping point, it will pay off. And this is usually after 2 weeks already. If you are more experienced, if you're better at getting a good design, this tipping point naturally moves to the left. So this is also a good measure to how good you are. If you are very skilled at designing code, if you are getting writing good code, then it doesn't pay off doing quick and dirty anyhow. So that's how I see it at least. This is Peck. Anyone know Peck? Okay, I recommend Googling him. He has done a lot or he has shaped our industry very much. He's the inventor of extreme programming. He's also, he rediscovered test-driven development, and he really brought test-driven development, which is now very popular, to life in around 2000. And he really shaped the agile, the agile software development methodology. And he's also one of the originators of the Agile Manifesto. So there is a lot he brought to our community. And he says, for each desired change, make the change easy, warning, this may be hard, and then make the easy change. And what does he mean by that? So he's saying that when you're doing a change and you want to do it, and the code does not really fit it, first you get the code into fitting the change. Maybe this takes 50 minutes, and then you do the actual change, and this takes only 10 minutes. And then you end up in better code, and you usually are even faster than just doing it quick and dirty. And what he means by this is also called refactoring. Refactoring is, by definition, making small changes in the code, in the structure of your code, to improve the design while maintaining the current behavior. So over these small changes, these are very small steps, the code will still do the same, but it will be differently structured to compensate for specific change or to have it more readable, for example. And this is refactoring. And I will show you later some examples of this, because I think that's very helpful for you. Refactoring is not changing behavior. So if you are fixing a bug, it's not refactoring. And if you rewrite your application, that's also not refactoring. If you maybe rewrite like 3 lines or a small function, you can count it as refactoring because it's a very small step. But the importance is really on small steps where every step leaves the code in a working state. Like if you take for a refactoring step more than 3 minutes, it's not really refactoring. So usually refactoring steps can take from 5 seconds to 1 minute or something. But if you are in more than 3 minutes of having code that is not compiling or not working, it's not really refactoring. I've been there, I've done a lot of this stuff where my code wasn't working for 2 hours, but it's not really refactoring. And you should be able to prove that everything still works after each change. There are ways to do this. For example, the IDEs today are very good at refactoring. the steps are, lots of the steps are automated, and these automated steps are safe to do. You just do them and you can be sure that everything still works afterwards. But for some refactorings, you will have to add unit tests, for example, to make sure that everything still works after the changes. All right, now let's get into the code. Talk is cheap. Show me the code. Let's start with very simple things. Okay, I will just show you very simple examples. With clutter. What is clutter? Anyone see problems in this code? The problem I see is that there is a function and that says add. So when I read this function, I know that it adds those two parameters. And then when I read the comment at the top, it also says adds A and B and returns the result. So the comment to me adds no value in this case, because the name of the function already tells me what the function is doing. I would just delete the comment because it's just 5 more lines that I don't want to read. Everything is in the function. Typically, you don't want to comment the what the code is doing. But a good tip is to comment why you are doing certain things. For example, you are running into an issue and you don't know how to solve it, and then you Google Stack Overflow, and then you find a solution, and you are doing this solution. Maybe you can put the link to Stack Overflow in your comment, so that if someone wants to know why you did that, and you have this link or some issue ticket or something. Could also help, just to explain your team players why you're doing things, not what you're doing. Always try to put the what you're doing in the names of the code. This is another example. This is a getter. This is from a class, an elevator class. It returns the floor, and it says get floor, and in the comment it says the same. It returns the floor. For me, this is also clutter. I would just delete it. Like, not all comments are bad. Some comments are really useful, but these comments are without value. In this example, this is also a function from an elevator. This method calls the elevator. And here is a conditional, and there is a comment on my way. And then there is some code that is here described with adds an intermediate stop, so that the elevator will stop there. And then there is something else. To me, this is already quite long. And I can't really follow the logic. It's a little bit complicated. So you can just, for example, you can just extract this code into a new function and call it add intermediate stop. Like this. Did you see that? First there was, sorry. First there is this box, the code, and then it's extracted. It's down there. And the function here says what it is doing. And this code got a lot smaller. It's much easier to read. And the function says what it is doing. And if you really want to know the details, you just look into the function. This is called extract method. And the IDEs usually can automate these things. Also, I'm not done yet. There is, for example, on my way. So there is a condition that says if on my way, so if the elevator is on my way, add an intermediate stop. So why is this so complicated here? Let's make this simpler. Just extract the method. Is on my way. Now it's down here, the code. And now you can very easily read it. If on my way, add intermediate stop. Simple as that. Just very simple steps that make the code easily readable, and you will get much faster doing it. Also, clutter is commented out code. I've been working on projects where there was so many commented out code, and everybody was afraid to delete it because they thought, okay, they probably need it, or that they don't know what it does, and maybe it's important. But honestly, if it's commented out like this, just remove it. You need to have the courage to remove commented out code. There is no reason to have commented out code in your code base. And if it is deleted and you still need it, you can just take it back from version control, from Git. So that's that. I would just remove it, and it gets much smaller, right? This is a good example. it's a function, and somebody commented. And somebody commented to do, maybe we need this later. Well, what is maybe? If it's commented out, it adds no value to the code, and it's there in version control if you need it later, so there's no point in having it and disturbing you from reading the rest of the code. Just remove it. Also, maybe you can't see the color, but this up away function, it is gray. It is gray because nobody's using it. If you have functions in your code that is not being used, just delete them. They are not adding value. They are just making your code longer. This one, this is grayed out, so you can just delete it. And this is an example. This is a function that adds values positively, like numbers positively. And here it is getting the positive value. So if it's negative, it will be positive then. And it's adding that. And then there is, if it's smaller than 0, make it positive. But actually, with this code, it will never be smaller than 0. So this code is unreachable. You will never get there. If you have something like this, also delete it. Yeah, it's not adding value. So this is what clutter is. And if you are just removing clutter, you are already doing a good thing to your code base. Next thing is you want to make it expressive. Is this expressive? I cannot understand what it's doing. The funny thing, it is just the same code from the slide before. It is the elevator code, but it just has very bad naming. So I just want to show you how important the naming is. If you just use like abbreviations or very small characters in your variables, nobody will know what you're doing. It doesn't matter if the names get a little bit long, just make them expressive. It's very helpful. Also lots of parameters. You have here a function that sends an email, and you have like 1, 2, 3, 4, 5, 6 parameters. And if you want to send the email to Max Mustermann, you have all these strings, and it's very easy to get them in the wrong order. Or you don't even know which parameter is which if you don't have this definition on your screen. It's very hard to figure this out. So what can you do? You can group these parameters. You can extract the parameter object and make it more expressive, like this. I grouped the first 3 parameters as the recipient object, and now it is descriptive. I can see, this is the first name, this is the last name, this is the email. I won't get it in the wrong order, and I know what everything is. And the same I can do for the second parameter. I can group these two. And this is much more expressive. Yeah. This is just small tips to help you get code better. Also, you want to make it simple. I'm seeing some of this code a lot when I'm reviewing code, and this is accidental nesting. This function is actually not doing very much. This function is really just checking if a string contains a hello, and then it is a welcome. That's all it is doing. But for this very simple thing, there is so much nesting, there's so many conditionals that it's really hard to understand what it is actually doing. And also, if you look closely at this if, it's marked as yellow. This is a hint by my IDE. It's called IntelliJ. I think WebStorm has this as well for JavaScript. It tells you that it could do something automatically. And if I move my mouse over it, it says if statement can be simplified. So let's try that. I just move the code to the left so you can compare it with the result. And this is what it does automatically. Like this if statement, it got the whole inner if else got simplified to this one line. Okay? But I'm not done yet. I don't like that there is now only if the string is not undefined, I want to do whatever the function does. I don't want the code to be like this. I want to have exit clauses in the top that check if it is not a valid input, if it is not defined or something, just return wrong, and then focus on what the function really does. So I will now flip this if. I move it to the left so you can compare. I'm flipping it. Now it's just flipped. It's gone from not equals to equals. And then I have to also flip the content. Now the return or whatever the function actually does is in the bottom. And I see already something like an exit clause. If someone sends me an undefined string, I just want to exit really quick. There's an exit clause. And I want this in the top. So now I can get rid of this else. It's not adding any value anymore. So I will remove the else. Bam. Now the else is gone. I would already be happy with this code. I have the exit clause in the top, and then what the function is actually doing. You could also do something like this to just remove the brackets. This is a matter of taste. You can even combine those two, but I like to have the exit clause explicitly in the top. That's a matter of taste. And you see if I go back to what it was originally, if you can compare this to the two lines, yeah, it's much easier to read and understand and easier to change. Okay, you want to eliminate duplication, and this is a big thing. Most of the code bases, they have at least 40% of duplication. And then if you fix a bug on some function, you don't know that there's another function that does the same thing, and the bug is still there. So that's what duplication is. I will show you very simple examples of duplication. This is a function that is taken from a card game, and this is the algorithm that shuffles the card deck. Okay, so it's just shuffling the cards in the deck, and if you can see here, there is 52. This is the size of the deck, the number of cards in the deck, and there is 53 minus I, and this is not by accident 53. This is the size of the deck plus 1, intentionally. So this is not by accident. So these numbers, they are in some way duplicated. This is also called magic number. If you find magic numbers like this, you can extract them like this. You just extract the constant deck size, it's 52, and then you use them here and here. And if you want to add more cards to your deck, you just have to change a single value. That's how you remove duplication. Let's look at this code. I'm creating a new player, 35, Pete, and 35. I have here 2 times the same number. Is this duplication? No. It's not good that you saw it. It's not duplication because those numbers, they change for different reasons. The one is the ID and the other one is the age. So if I changed the age, I would change his ID. That's not what I really wanted. I just wanted to change his age. So this is not duplication. And there is also functions that look sometimes exactly the same, but if they change for different reasons, those functions are not duplication. And you have to take care about this. Sometimes if you remove those duplications that change not for the same reason, you make your life harder. Yeah. So when do you want to refactor? You want to do it continuously, like all the time when you're working on code. You do it before you make a change. You make the change easy. And when you're done making a change, you clean the kitchen. And if you do it like this, you just end up with very clean code and you probably end up very fast. And also, I've often seen refactoring as an item on the backlog. I do not recommend refactoring to even have it as a ticket or an issue. It's something that is definitely not on the backlog. And if it is on the backlog, then it is not important to you right now. Or if it is important, then you should do it right now. So there is really no reason to put refactoring in a backlog. You should do it always, and that's that.
10 minutes.
Okay, so what to refactor? You want to refactor code that is just related to your current work. If you have lots of modules that you're not working on, just leave them like they are. Maybe you don't need to refactor them. It's not adding any value to you. You probably need a suite of fast unit tests that verify that after each step, the code is still working. This vastly improves the confidence in your code because you don't have to run it and then test it and so on. You just execute your tests, and if they're finished, hopefully in like 1 second, and then you're confident everything still works, you can do very nice refactoring. So unit tests enable refactoring. Refactoring enables better design. Better design enables easy changes, and easy changes make happy coders. That's what I think. There is one workflow for refactoring. It's test-driven development, where when you code, you start with a unit test, and after you have written the unit test, you make it pass as simple as possible. The test is then working, and then when you make the test working, then you go into refactoring. When you're done refactoring, you add the next unit test. And this is a cycle, and it makes you add all the tests you need to do safe refactorings in your code base. Maybe some of you know the Factorial game. I have played in early access, and it had no bug, no crash whatsoever. I played other early access games, and they crashed all the time. And the funny thing is Factorial, they are doing test-driven development in their game. And that's probably why they have no bugs. And on Reddit, someone posted that they had a crash, 54 minutes, and then 10 minutes later, the developer gave an ATA. In 1.5 hours, the bug will be fixed. And that's good performance, right? That's really good performance.
What is ETA?
ETA says that it will be estimatedly fixed in 1.5 hours. I don't really know what the abbreviation, what the words for the abbreviation are. Maybe
estimated time of arrival.
Estimate time of error. Okay, thank you for that. Yeah. Yeah, I will now quickly go over this. I already said this. This is not as important. I recommend trunk-based development. Maybe you have seen this workflow where the people are working in feature branches for a long time. And that's very problematic because if you are in a feature branch for 1 week and you are just changing a function that is used all over the place in your code base, when you are merged, you get into conflicts. And you know this. And so you're probably then, you are scared of doing refactoring in these branches. So that's not a good idea. You want your workflow to enable refactoring. So you don't want to go into feature branches. It's much better to, if all your people are committing to the same branch. And then if you have very small changes very frequently, the risk is reduced. So the smaller the steps, the much smaller the risk becomes, and you probably don't end up with conflicts at all. Or if you do, if you end up with a conflict, the conflict has to be very small because it's just about a single commit. And if you do very small commits, then the risk is very low. So you should also do small commits and commit very often, like once every 10 minutes you can commit. Tooling. I recommend using an IDE because they have lots of these refactoring steps automated. I have a video here. It takes just 1 minute. It just demonstrates with a little bit of Java code how the steps are automated. This is a video where it is refactoring from an old Java version to a new Java version. And it's using the mouse, but you can do this all with your keyboard. Just Alt-Enter. All these steps are tiny, and they are all safe because the IDE guarantees that they are safe. So for this refactoring, you don't even need unit tests. Yeah, it's much shorter now. So it was really awful in the beginning, like awful. Okay. I also recommend trying to not use your mouse as much. There is a good tip that you can do. Try to move your mouse to the other side of the keyboard. Like that when you try to reach for the mouse, there is no mouse. And try to force yourself into using only the keyboard and really finding all the shortcuts that you need in your IDE to get the coding done. There is a shortcut for committing, for pushing, for pulling, for doing refactorings, for moving code around. There's shortcuts for everything. You can really, if you're in an IDE, you don't need your mouse. And the mouse just slows you down. And it's not really that hard to get into using the keyboard. It's just like you just have to start, and then after some weeks, you're probably already into it. Pure functions and immutable objects are easier to refactor. So you want to write these. Usually when you're refactoring, you have to break dependencies. And dependencies of state are much harder to refactor. And if you're doing pure functions and immutable objects, there is no state dependency involved, so it's easier to refactor. Deepest branch first. So if you have lots of nestings, like if, else, if, switch, while, and you want to refactor the code because it's so complicated, start at the deepest branch, like the lowest branch. Then you will have a much easier life. If you start at the very top, it is very likely that you get stuck. This is what I not recommend. and practice, a lot of practice. There is lots of practice examples online. I have them in my slides. You can look them up later. Katas are, this is taken from karate, where you practice fighting against an imaginary opponent. And in this case, the opponent is the code. And you have to refactor some very complex code. And they are online. They are available in all sorts of languages. And you can just get started into practicing. And if you don't know what to do really, just Google them or find them on YouTube, and you will see someone else doing it, and you can learn from what they did. Yeah. And what if you're not allowed to? There are companies where you will not be allowed to do refactor or to write tests. There are companies like this. And Uncle Bob has something to say about it. And he says, never ask for permission to refactor. Never ask for permission to write tests. You do these things because you know that they are the best way to go fast. And when you ask for a permission, you are asking someone else to take responsibility for your actions. So you don't want to give someone else the responsibility what you're doing with your code. The customer can decide what the code should be doing, but you are deciding on the design and how you do, and if you need unit tests and if you need refactoring. That's your choice, because you are the one working on the code. And one last tip. Working on a greenfield is exciting, it is fun, but you should not underestimate the lessons that a poor legacy code base can teach you. I've been working on some of these very old, very bad code bases, and I believe that they have probably taught me more than greenfield projects. It was frustrating at times, but it really improved my skills in refactoring and clean code and so on. And because you really learn what you don't want to do. And this is also a lot of value if you want to improve. So don't underestimate this. If you get into such a project, don't bait out right away. Maybe try and get advantage of it. I want to recommend some books on this topic. This is the one on the left is the original refactoring book by Martin Fowler. It's written in Java. It's from, I think, around 2000. There is now a second edition, also by Martin Fowler. It is completely filled with examples only in JavaScript, so it's maybe more up to date. And the Mikado method is a methodology how to do refactoring. I don't want to get the details now because I don't have the time. Working Effectively with Legacy Code by Michael Feathers is a very old book, but it has lots of very helpful tips with working on legacy code and refactoring. So it's an excellent book. I really recommend it. And also Clean Code by Robert Martin. This is where you want to end when you do refactoring. You always want to end with clean code. Also, I have these books here. Sorry, I'm going out of the camera. If you are interested in these books, you can look at them here. Maybe you find something that gives you value. But I will take them home. So yeah, that's all. Thank you for listening.